Hello and welcome to the course, Product Carbon Footprint for Companies. My name is Sir Giarfalis. Before we begin, I want to let you know that if you have any questions during the course, or if you need further information or customized training for your company, you can either send me a message through the comment box or contact me directly through my social media or my website, sirgiarfalis.com. In this training, we will explore how to measure, interpret, and use the carbon footprint of your products to drive both sustainability and business value. The course is organized into 8 sections: Introduction, PCF Methodology and Standards, Application of PCF in Companies, Interpreting and Using PCF Results, Communication and Reporting, Challenges and Best Practices, a practical workshop or case study, and finally, a wrap-up. Whether you are from a small or large company, this course will provide you with practical tools and real examples to help you integrate product carbon footprinting into your sustainability strategy. Let's get started. What is a product carbon footprint, or PCF? A product carbon footprint measures the total greenhouse gas emissions generated throughout the life cycle of a product. This includes emissions from raw material extraction, manufacturing, distribution, use, and end-of-life disposal. The result is expressed in units of carbon dioxide equivalent, which allows us to compare and aggregate the impact of different greenhouse gases on a common basis. It's important to understand that PCF is different from an organizational carbon footprint, which measures the total emissions of a company as a whole. PCF is also different from a life cycle assessment, or LCA, which considers multiple environmental impacts, not just carbon emissions. To calculate a PCF, we multiply the activity data, such as the amount of material or energy used, by the environmental factor, which is the amount of greenhouse gas emitted per unit of activity. For example, if an engine consumes a certain number of kilograms of diesel, we multiply that by the emission factor for diesel to find the total emissions in CO2 equivalents. This approach allows companies to understand the specific climate impact of each product and to identify where the biggest opportunities for improvement exist. What is a carbon dioxide equivalent? When companies or organizations measure greenhouse gas emissions, they are not just dealing with carbon dioxide. Other gases, such as methane, nitrous oxide, and various industrial gases, also contribute to global warming, but each one has a different strength and lifetime in the atmosphere. To make these different gases comparable, scientists use a unit called CO2 equivalents. The Intergovernmental Panel on Climate Change, or IPCC, assigns each greenhouse gas a global warming potential, or GWP, which tells us how much more or less powerful it is compared to carbon dioxide over a standard period, usually 100 years. For example, methane has a GWP of about 28, meaning it is 28 times more powerful than carbon dioxide in warming the planet. To calculate the carbon dioxide equivalent, you multiply the amount of each greenhouse gas by its global warming potential. This way, all emissions can be added up and reported as a single, comparable number, making it easier to understand and communicate the total climate impact of a product or activity. Why is product carbon footprint important for companies? Understanding and managing the carbon footprint of your products is more important than ever for today's businesses. New regulations, such as the European Green Deal and national carbon reporting laws, are making it necessary for companies to take responsibility for the emissions associated with their products. At the same time, customers, business partners, and investors are increasingly demanding more sustainable products and greater transparency throughout the supply chain. By measuring and reducing your product carbon footprint, your company can manage risks, identify opportunities to save costs, improve your brand reputation, and gain a real competitive advantage in the marketplace. Product carbon footprint is also a key tool for your sustainability and climate action strategy. It enables your business to set science-based targets, work towards net zero goals, and drive decarbonization across your value chain. By focusing on product-level emissions, you can make more informed decisions about materials, design, sourcing, and production processes, supporting both environmental responsibility and business success. The main phases of the product carbon footprint methodology are equivalent to the phases of a life cycle assessment, or LCA. If you want to learn more about LCA and its phases, you can find a detailed video on my channel. Let's go through the key phases for calculating a product carbon footprint. The first phase is defining the goal and scope. Here, you clarify why you are doing the assessment, what product you are analyzing, what the functional unit is, and which life cycle stages you will include. This step ensures your results are relevant and comparable. The second phase is the inventory of data. In this step, you collect all the necessary information across the product's life cycle, such as material and energy use, transportation, and waste. This often requires collaboration between different departments within your company. After gathering your data, you move to the impact assessment phase. Here, you use recognized calculation standards, like ISO 14067, to convert your activity data into carbon dioxide equivalents using the appropriate emission factors. The final phase is interpretation. This is where you analyze the results to identify emission hotspots, develop mitigation plans, and communicate your conclusions to stakeholders. By following these phases, goal and scope definition, data inventory, impact assessment, and interpretation, you can systematically measure, understand, and reduce the carbon footprint of your products, just as you would in a full life cycle assessment. The first step in the product carbon footprint methodology is to define the goal and scope of your study. This is a critical phase because it sets the direction for the entire assessment and determines how useful and relevant your results will be. Start by selecting the product you want to analyze and clearly stating the purpose of your PCF study. For example, your goal might be to respond to a customer request, to meet a regulatory requirement, or to support your company's internal sustainability strategy. It's also important to identify the intended audience for your results, as this will help you decide the level of detail and the standards you need to follow. Next, define the functional unit. The functional unit is a precise, quantitative reference that describes the function or service provided by your product. For example, it could be 1 kilogram of plastic compound delivered to the customer, or 1 carton of orange juice ready for consumption. This allows for meaningful comparisons and ensures all emissions are reported on a consistent basis. You also need to set the system boundaries for your study. Decide which life cycle stages you will include, such as raw material extraction, production, transport, use, and end of life. For some studies, you might only consider cradle-to-gate, which stops at the factory gate, while others may require a full cradle-to-grave analysis. Finally, consider any assumptions or exclusions you are making. For instance, if certain stages or materials have a negligible impact or are the same for all compared products, you may decide to exclude them, but always document your reasoning. By carefully defining the goal and scope, the functional unit, and the system boundaries, you ensure your product carbon footprint study is robust, transparent, and tailored to your company's needs. Let's talk about collecting data for your product carbon footprint calculation. To get reliable results, you need to gather activity data for every relevant stage of your product's life cycle. This includes quantities of materials and ingredients used, energy consumed, distances and modes of transport, packaging, and waste generated. You will usually collect this information from different departments in your company, such as production, logistics, and purchasing. Whenever possible, use primary data from your own operations, as this is more accurate and reduces uncertainty in your results. Sometimes, you may need to use secondary data, standard values published in scientific literature or industry databases, when you cannot obtain specific data from your company. Examples of reliable databases include Ecoinvent and Sphera for general data, Carbon Mines for chemicals, Agribalyse for agri-food, and Plastic Europe for plastics. Public organizations, such as government agencies, also publish environmental factors for electricity, fuels, and transportation. Once you have your activity data, you will also need to collect or calculate the emission factors for each activity. These are standardized values that tell you how much greenhouse gas is emitted per unit of activity, such as per kilogram of material or per kilowatt-hour of electricity. By combining your activity data with the right emission factors, you will be able to calculate the carbon footprint for each stage of your product's life cycle and sum them for the total product carbon footprint. For example, if your process uses 0.3 kilowatt-hours of electricity per kilogram of product, and the emission factor for electricity in your region is 0.324 kilograms of CO per kilowatt-hour, you multiply these values to get the emissions from electricity use. You repeat this for each material, transport route, packaging, and waste treatment stage. Once you have calculated the emissions for every stage, you sum them up to get the total product carbon footprint for your defined functional unit. This step-by-step approach allows you to see which parts of your process have the biggest impact and helps you identify opportunities for improvement. Now let's look at how to calculate emissions for your product carbon footprint with a realistic case example. The core of the calculation is simple. For each activity in your product's life cycle, you multiply the activity data by its corresponding emission factor. Activity data could be the amount of electricity used, the weight of each material, or the distance and method of transport. The emission factor tells you how much greenhouse gas is released per unit of that activity, usually expressed in kilograms of co-equivalent. You can see here in the slide the statement of the task we are about to solve, including the stages that we are considering and the stages that we decided to neglect. Here, we have collected the activity data corresponding to each stage of the process. This data would be normally collected from different departments within the company. It can be also guessed or calculated in case we cannot track the information with our data system. I want to take a short pause to talk, before continuing, about how to calculate the total kilogram times kilometer when we have multiple suppliers. When calculating the transport impact in your product carbon footprint, it's important not to simply add up all the kilometers from different suppliers and multiply by the total weight. This shortcut can lead to a significant overestimation of the emissions. The correct method is to calculate the transported weight multiplied by its specific transport distance for each supplier and each material. This gives you the correct value in kilogram-kilometers, or kilogram times kilometer, for each transport route. Once you have calculated the kilogram times kilometer for each material and route, you then sum all these results to get the total transport activity. For example, in our case with the plastic compound, for a functional unit of 1 kilogram of product, we have 0.5 kilograms of recycled polypropylene transported 50 kilometers by road, which equals 25 kilogram times kilometer. We have 0.33 kilograms of virgin polypropylene transported 100 kilometers, that's 33 kilogram times kilometer. 0.15 kilograms of carbon black are transported 2,000 kilometers, gives 300 kilogram times kilometer, and for 0.02 kilograms of inorganic pigment transported 300 kilometers by road and 8,000 kilometers by ship, resulting in 6 kilogram times kilometer by road and 160 kilogram times kilometer by ship. If you simply summed all the distances, for instance 50 kilometers plus 100 kilometers plus 2,000, and so on, and multiplied the result by the total weight, 1 kilogram corresponding to the sum of the raw materials, you would get an inflated result that does not reflect the real transport emissions. Always calculate each transport route separately, then add them together for an accurate and credible PCF calculation. Okay, now let's review how we collect and use environmental factors for our product carbon footprint calculation. In this example, our goal is to calculate the PCF of a plastic grade composed of 50% recycled polypropylene, 33% virgin polypropylene, 15% carbon black, and 2% inorganic pigment. We want to communicate this result to our customer, who has requested it. The boundaries are set as Cradle-to-gate, and the functional unit is 1 kilogram of plastic. The next step is to collect the environmental factors for each input and process. To measure the electricity consumed by pretreatments outside our facilities, since our suppliers are in Europe, we use the average environmental factor for the electricity in that region. To measure the electricity consumed by ourselves, we ask our electricity provider for their specific environmental factor and adjust it to account for the solar panels installed at our facilities. We also gather general environmental factors for road and ship transport, landfilling, and incineration. For materials, we use the environmental factor for LDPE bags and virgin PP from Plastic Europe, the environmental factor for inorganic pigment from Eurocolors, and we request the environmental factor for carbon black directly from our supplier. The table on the right lists the environmental factors for each input, measured in kilograms of CO2 equivalent per unit. For example, electricity in Europe has an environmental factor of 0.324, transport by road is 0.0002, and PP virgin is 1.63. By collecting these environmental factors for each relevant input and process, we ensure our calculation is transparent, consistent, and based on reliable data sources. Notice that the EF for recycled PP is 0. Why? This is because of the cutoff methodology, also known as the 100 to 0 approach. In this system, all emissions from the original production of virgin material are fully assigned to the first product life cycle. When the material is recycled and used again, only the emissions from the recycling process itself, such as collection, sorting, and reprocessing, are counted for the recycled product. The recycled material is considered burden-free from its previous life, and this avoids double-counting emissions across different products. This approach is simple and transparent, and it encourages the use of recycled materials by giving them a lower carbon footprint. There are other allocation methods you might encounter. The 0 to 100 approach, also called the substitution or avoided burden method, works differently. Here, the recycled product takes on the full burden of the original production, but it also gets a credit for replacing virgin material at the end of its life. This means the environmental impacts of recycling are shifted to the recycled product, and the system gives a benefit for avoiding the need to produce more virgin material. A third method, used in the product environmental footprint or PEF approach, is the 50:50 split. In this case, the impacts and benefits of recycling are shared equally between the original product and the recycled product. Each approach has its own logic and consequences for how emissions are assigned. The cutoff, or 100 to 0 method, is widely used in industry databases like Ecoinvent and is accepted by standards such as ISO 14067 and the GHG Protocol. It is important to clearly state which methodology you use in your calculations, as it can significantly affect the carbon footprint result for recycled materials. Let's look at the final results of our product carbon footprint calculation for the plastic grade example. As shown in the table, each input and process, like electricity use, transport, raw materials, packaging, and waste, contributes a certain amount of emissions, measured in kilograms of CO2 equivalent per kilogram of plastic. For example, virgin polypropylene and carbon black are the largest contributors, while recycled polypropylene, under the cutoff methodology, has an emission factor of 0. When we sum all the contributions, the total product carbon footprint comes out to 1.132 kilograms of CO2 equivalent per kilogram of plastic. This result gives us a clear, quantitative basis to identify emission hotspots and prioritize actions for reducing the carbon footprint of our product. Imagine now you have a process that produces two materials, product A and product B. The total carbon emissions from this process need to be assigned, or allocated, between both products. In our example, the process produces 10 kilograms of plastic A and 90 kilograms of plastic B. Plastic A sells for $90 per kilogram, while plastic B sells for $10 per kilogram. There are two main ways to allocate these emissions. With mass allocation, you split the emissions based on the weight. Since we produce 10 kilograms of A and 90 kilograms of B, the allocation would be 10% to A and 90% to B, based on mass. This approach works best when the products have similar economic value or when emissions are directly related to the amount produced. With economic allocation, you split the emissions based on the market value of each product. Even though we produce more of B by weight, each product generates the same total revenue, $900 each, so the allocation would be 50% to A and 50% to B. Economic allocation is preferred when the co-products have very different values. When comparing products with different functionalities, like a more durable plastic versus a less resistant one, you may need to adjust your calculations to ensure fair comparisons. In these cases, you should compare the emissions per functional unit, making sure both products are delivering the same service. For example, if plastic A lasts twice as long as plastic B, you only need half as much of A to provide the same performance over time. By choosing the right allocation method and adjusting for product function, you ensure your PCF results are meaningful and useful for decision-making. How can we assess the quality of our data? What is Data Quality Rating, or DQR? The DQR is a scoring system used in the environmental footprint method to assess how reliable and robust your datasets are in a product carbon footprint or life cycle assessment study. It helps you determine if your data is suitable for use in a product environmental footprint calculation. DQR evaluates each data source you are using across 5 key criteria. First, technological representativeness, which measures how well the technology in your dataset matches the actual process you are modeling. Second, geographical representativeness, which checks if your data reflects the real location of your operations. Third, time-related representativeness, which looks at how current your data is compared to the period of your study. Fourth, completeness, which ensures all relevant flows and impact categories are included. And fifth, precision and methodological appropriateness, which considers the reliability of your data sources, collection methods, and how rigorous your methodology is. Each criterion is rated from 1, meaning very good, to 5, meaning very poor. The overall DQR is calculated using a weighted formula, giving more weight to the first 3 criteria. A lower DQR score means higher data quality and more reliable results. By using the DQR system, you can transparently assess, track, and improve the quality of your data, making your product carbon footprint calculations more credible and robust. Now let's explore the main standards and methodologies for product carbon footprint calculations. All these standards are built on the principles of life cycle assessment and aim for alignment with the latest IPCC guidance. The choice of standard depends on the product, industry, regulatory requirements, and the intended use of the results. ISO 14067 is the internationally recognized standard specifically for quantifying and communicating the carbon footprint of products. It is based on the broader ISO 14040 and 14044 life cycle assessment standards and provides detailed requirements for calculating greenhouse gas emissions across a product's life cycle. ISO 14067 is widely accepted and often serves as the foundation for other sector-specific guidelines. The GHG Protocol product standard was developed by the World Resources Institute and World Business Council for Sustainable Development. This standard offers a framework for measuring and reporting product greenhouse gas emissions from production to disposal. It is designed to ensure consistency and transparency, and is often used alongside ISO 14067 for broader compliance. PAR 2050 was created by the British Standards Institution and was the first widely used carbon footprint standard. It is applicable to most products and provides a practical approach for calculating life cycle greenhouse gas emissions, though it is less detailed than ISO 14067 and does not fully address land use changes. The Product Environmental Footprint, or PEF, is recommended by the European Commission. PEF is a multi-criteria LCA method that covers a wide range of environmental impacts, including climate change. For PCF purposes, only the climate change indicator is used. PEF aims to harmonize product footprinting across the EU and is increasingly referenced in regulatory contexts. Finally, there are sector-specific guidelines, such as the TFS PCF guideline and PACT methodology. Industry groups and alliances, such as Together for Sustainability and the WBCSD's PACT, have developed these sector-specific guidelines to address unique industry needs while aligning with ISO 14067 and the GHG Protocol. These guidelines help improve data quality, consistency, and comparability, and facilitate data exchange across supply chains. How can you implement PCF in your sustainability strategy? Welcome to CEO's Playbook. With this roadmap, you will get an overview on how to start footprinting your products. Okay. Start with a pilot project. Choose one or two flagship products, perhaps your bestseller or a product with a simple supply chain, and calculate their PCF. This approach reduces complexity and costs while helping your team build internal expertise. Next, leverage digital tools to speed up the process. Use specialized PCF or LCA software, such as CymaPro, Sphera, or OpenLCA, or even develop your own tools in Excel or code. Identify where to collect data from, create mechanisms to avoid bottlenecks, and simplify the process while maintaining accuracy. Once you have your data, turn it into decarbonization actions. Identify emission hotspots, such as raw materials or energy-intensive processes, and implement quick wins like switching to recycled or renewable materials, optimizing logistics, or shifting to renewable energy in manufacturing. It's also essential to engage your supply chain. Require suppliers to report PCF data for purchased materials, since up to 80% of a product's emissions often lie in the supply chain. Align your PCF efforts with business goals by linking reductions to key performance indicators, such as the percentage of emissions cut per product or revenue from low-carbon products. This ensures that PCF becomes part of your company's overall strategy and performance measurement. Communicate transparently. Publish your PCF results in annual sustainability reports and on product labels. Use PCF data in marketing to attract eco-conscious customers and build trust. As you gain experience, scale PCF tracking across your entire product portfolio, using lessons learned from your pilot project. For large enterprises, consider deploying centralized PCF teams to standardize methods globally. Finally, make continuous improvement a habit. Update your PCF calculations annually, or whenever processes change, using ISO 14067 guidelines. Benchmark your results against competitors and industry standards to stay ahead. By following these steps, your company can turn PCF from a technical exercise into a strategic tool for innovation, risk management, and long-term business success. Interpreting and using product carbon footprint results means turning raw emissions data into actionable insights for your business. After calculating the PCF, the first step is to analyze the results and identify carbon hotspots. These are the specific life cycle stages, materials, or processes that contribute most to your product's total emissions. For example, you might discover that raw material extraction or a particular manufacturing process is responsible for the majority of your product's carbon footprint. This information is crucial for prioritizing your reduction efforts and making informed decisions about product design, sourcing, and production. By focusing on these hotspots, your company can set realistic emission reduction targets, choose more sustainable materials, optimize logistics, or redesign products for lower impact. Ultimately, interpreting PCF results helps you drive continuous improvement and make your sustainability strategy more effective. With a well-modeled process, you can also forecast the PCF of future product formulations or scenarios, using your historic data as a basis. For example, you can recalculate your emissions if you increase the share of renewables in your electricity mix, or if you change a supplier. It's also important to use your PCF results to engage suppliers and optimize your supply chain. Sharing your findings with suppliers can encourage collaboration on more sustainable sourcing and transport options and help drive improvements throughout the value chain. For instance, IKEA uses PCF data to work closely with suppliers and set ambitious reduction targets for both product use and end-of-life emissions. Clear, transparent, and credible communication of your product carbon footprint results is essential for building trust, meeting stakeholder expectations, and complying with regulatory requirements. Start by knowing your audience and your objective. Adapt your message for customers, investors, suppliers, regulators, or employees, as each group will have different interests and information needs. Always use recognized standards and frameworks, such as ISO 14067 or the GHG Protocol product standard, to ensure your reporting is consistent, comparable, and credible. Be fully transparent about your methodology, data sources, and any limitations or uncertainties in your results. Good data quality is key to building confidence in your findings. Whenever possible, seek third-party verification or assurance to further increase the credibility of your results. Tell a story with your data. Use visuals, charts, and real-world examples to make your results engaging and easy to understand. Finally, avoid greenwashing. Be honest about both your achievements and your areas for improvement. Avoid vague claims like carbon neutral unless you can provide clear evidence and supporting information. On this slide, you can see the recommended structure for reporting a product carbon footprint following the ISO 14067 guidelines. This structure is designed to ensure that your reporting is transparent, credible, and useful for both internal and external stakeholders. We begin with the introduction and goal of the study. Here, you state the purpose of your PCF assessment, whether it's for regulatory compliance, customer requests, or internal improvement, and identify the intended audience and commissioner of the study. This sets the context for the entire report. Next is the product system description. This section describes the product, defines the functional unit, the reference against which all emissions are measured, and sets the system boundaries. You also detail which life cycle stages are included, such as raw material extraction, manufacturing, distribution, use, and end of life. The third section is the methodological framework. Here, you document the standards and guidelines you followed, your allocation procedures, any cutoff criteria, and the data sources you used. It's also important to be transparent about any assumptions and limitations, as these can influence the results. Section 4 covers the PCF inventory data. This is where you explain how you collected your data and how you assessed its quality. High quality, well-documented data is essential for a robust carbon footprint calculation. The fifth section is the calculation itself. You present the methods and formulas used to quantify emissions, ensuring that your approach can be reproduced and verified by others. In the presentation of results, you highlight the key findings, such as the main emission hotspots in your product's lifecycle, and provide recommendations for mitigation or improvement. This is where your analysis becomes actionable. Finally, you include annexes if needed, such as detailed data tables or evidence of third-party verification, which can add credibility and transparency to your report. By following this structure, you align your reporting with international best practices, making your results both trustworthy and comparable. This not only facilitates compliance and stakeholder confidence, but also supports better decision-making for sustainability across your organization and value chain. When it comes to communicating and reporting your product carbon footprint results, there are several effective channels and formats to consider. First, include your PCF results, reduction targets, and progress in your annual sustainability or ESG reports. This demonstrates transparency and commitment to your stakeholders. Second, use product labels to communicate the carbon footprint directly on packaging or product websites. You can use numerical labels, such as 2.5 kilograms of CO2 equivalent per unit, or comparative labels, like an A to E scale. Well-known labels, such as the Carbon Trust label, help customers quickly understand your product's climate impact. Third, take advantage of digital platforms. Create dedicated web pages or dashboards with detailed PCF data and explanations. You can also use QR codes on packaging to give customers instant access to more information. Fourth, share your PCF data with business customers and suppliers through supply chain data exchange platforms. Use standardized digital solutions, such as those following the PACT methodology, to ensure consistency and comparability across your value chain. And, as we always warn, avoid making vague claims unless you can provide solid evidence, because such claims can backfire and harm your credibility in the medium or long term. Let's review the main challenges and best practices when implementing product carbon footprint in companies. On the left, we see the key challenges. First, data quality and availability. most organizations struggle to obtain sufficiently granular, accurate, and verified primary data. Second, supplier data collaboration. PCF assessments require data from across the value chain, so engaging suppliers is critical but often challenging. Third, complex emissions allocation. Allocating emissions from shared processes or co-products can be complicated, especially when product category rules are inconsistent or missing. Fourth, lack of robust, scalable systems. Many companies need flexible digital solutions that can handle large, distributed datasets and adapt to new regulatory requirements. And finally, standardization and comparability. With so many standards and methodologies, plus confidentiality concerns and inconsistent data formats, it can be difficult to ensure results are comparable and benchmarking is possible. On the right, we have best practices to address these challenges. First, invest in data governance and quality management. Establish clear data governance structures, assign data ownership, and implement policies for data quality, validation, and regular review. Second, engage and support suppliers. Provide guidance, training, and digital tools to make data collection easier and improve data quality throughout your supply chain. Third, use fit-for-purpose digital solutions or create your own tools. Adopt scalable PCF and LCA software that integrates with your business systems, automates calculations, and supports scenario analysis. Fourth, align with recognized standards and product category rules. Follow internationally accepted standards like ISO 14067, the GHG Protocol product standard, and sector-specific PCRs to ensure consistency and comparability. And finally, where possible, seek third-party verification. This adds credibility and trust to your results. Okay, now let's pause for a moment and look at these apples on the screen. Imagine you're in a supermarket, faced with 3 different options. Each apple comes with its own price and a set of environmental and social attributes. Some are local, some are organic, some are imported by plane, and some have social or ethical issues attached. Now, I want you to think, which one would you choose? And more importantly, why? This is not a trick question. This is the real challenge of sustainability in practice. Many people, and even many companies, would like to believe there's always a clear, single answer. But in reality, the most honest response to which product is more sustainable is often, it depends. Let's unpack that. What does it depend on? It depends on your context and priorities. Are you most concerned about carbon footprint and climate change? Or do you care more about water use, land use, pesticide residues, fair labor practices, or supporting local farmers? What about price? Does affordability matter most to you or your customers? And what if reducing carbon dioxide means accepting other trade-offs, like increased use of hazardous chemicals or social issues? Now, let's connect this to product carbon footprint. PCF is a powerful tool. It gives us a number, a measurement, that helps us compare products on climate impact. But can we say that the product with the lowest PCF is always the best choice? Clearly not, because sustainability is multidimensional. If we only look at carbon, we might miss water scarcity, biodiversity loss, or human rights abuses. So here's my challenge to you. What information do you wish you had to make a better decision in this case? Should we always prioritize the lowest carbon footprint, or are there situations where other factors should come first? How would you communicate these trade-offs to a customer or stakeholder? Let's debate. Is it possible to create a single sustainability score for products, or do we need to accept that context and priorities will always play a role? Have you ever faced a similar dilemma in your own life? How did you resolve it? Please, send your opinion through the comment section. Let's dive now into another real-world example that perfectly illustrates why context matters so much in sustainability. Imagine you're deciding which type of cutlery to use for serving a meal. On land, in a typical restaurant setting, the comparison is pretty straightforward. You might look at stainless steel, wood, or plastic cutlery and compare their carbon footprints per use. Usually, the reusable stainless steel comes out on top after enough uses, because its impact is spread over a long lifespan, while single-use wood or plastic cutlery generates much higher emissions per meal. Here you can see their PCF, for instance. But now, let's change the context. What happens if we move this decision onto an airplane? I will give you a few seconds to think about it. We have the same materials. But here the rules of the game change completely. On a plane, every gram counts, because extra weight means extra fuel consumption, and that means more emissions. Suddenly, the carbon footprint of the cutlery isn't just about its production or disposal, but also about how much it weighs. In the aviation case, studies show that the heavier, reusable stainless steel cutlery, while sustainable on land, can actually have a much higher carbon footprint in flight, simply because transporting that extra weight over thousands of kilometers burns more fuel. In fact, as shown in this example, the PCF for stainless steel cutlery on a plane can be more than 10 times higher than for lightweight single-use plastic. The wood option, which is heavier than plastic but lighter than steel, falls somewhere in between. So, what's the lesson here? The best material depends entirely on the context and the functional unit you define. On land, durability and reusability win. In the air, weight becomes the dominant factor. To wrap up, let's revisit the main takeaways from this course on product carbon footprint for companies. Product carbon footprint, or PCF, measures the total greenhouse gas emissions of a product throughout its life cycle. This approach allows companies to identify emission hotspots and drive targeted reductions where they matter most. Implementing PCF is not just about compliance, it helps companies meet regulatory requirements, respond to customer and market expectations, and gain a competitive edge through transparency and sustainability. Achieving accurate PCF results requires a clear definition of your goal and scope, robust data collection, the use of recognized standards like ISO 14067 and the GHG Protocol, and ongoing engagement with your suppliers. Interpreting your PCF results is essential for informed decision-making, product innovation, and effective communication, both internally and externally. It empowers your teams to make better choices and demonstrate real progress to stakeholders. Finally, while challenges such as data quality and supplier collaboration can be significant, they are not insurmountable. With digital tools, best practices, and a commitment to continuous improvement, companies can overcome these barriers and unlock the full value of PCF. Thank you for your attention and participation. Remember, measuring is the first step to improving. If you have questions or want to go further, don't hesitate to reach out.